Class 10, we had to start exercise 6.5. The first question here is saying the sides of the triangle are given below. You have to determine which of them would be a right angle triangle. In case of right triangle, you have to guess, find the length of hypotenuse. Okay, so now children, what happens here is we have studied Pythagoras theorem for right angle triangle, which says that square of the hypotenuse is equal to square of the sum of the square of the other two sides. So when three dimensions or three sides are given to you, and hypotenuse we know is the largest side. Okay, last year you had that theorem. Okay, because right angle is the biggest angle possible in a right angle triangle, so side opposite to right angle has to be the longest side. Okay, so hypotenuse automatically is the largest side or the longest side we have in a triangle. So when I have you have been given three dimensions here, so the longest one, the biggest of the measurement out here would correspond to hypotenuse, if at all. Okay, so for verifying Pythagoras theorem, we will find the square of the largest side. Okay, and then find the sum of the other two square of the other two sides. The remaining two sides were 7, so 7 square plus 24 square. Do that calculation. So 7 square plus 24 square is coming out to be 625. That means you've got 7 square plus 24 square is equal to 25 square. This satisfies your Pythagoras theorem. Hence, these three would be sides of a right angled triangle. Okay, and then they had said what would be the hypotenuse. I've told you largest side has to be the hypotenuse. Okay, now if you see the second part there, now in the second part what is happening, children? The dimensions given to you were 3, 6 and 8. So the longest side square, 8 square, which is 64. Then the sum of the square of the other two sides. So 3 square plus 6 square, 9 plus 36, which is 45. This is not coming equal now. So this time we have got 3 square plus 6 square not equals to 8 square. Hence, this would not be representing a right angled triangle. So that is all you all need to do here, children. Okay. Now, but what you have to make sure is do these calculations separately. ओके सो आप बच्चे क्या कर देते हैं 3 स्क्वायर प्लस 6 स्क्वायर इज इक्वल टू 8 स्क्वायर, फिर कैलकुलेशन करके नीचे दिखाते हो ये तो आ गया 45, ये आ गया 64. दैट लुक्स क्वाइट एब्सर्ड वियर्ड. ओके, सो यूल डू इट सेपरेटली. लॉन्गेस्ट ऑफ द थ्री डायमेंशन उसका स्क्वायर आप सेपरेटली करो एंड sum the square of the other two smaller sides and then check if they come out to be equal like happened in first case, that is a right angle triangle, and if they are not equal, then you would say it is not a right angle triangle. The remaining two parts likewise try on your own. Now the second question that you have, that PQR is a triangle which is right angled at P and M is point on QR such that PM is perpendicular to QR. Then you have to show that PM square is equal to QM into MR. Okay, so first we'll make, so here is your triangle PQM, which is right angled at P, and then from P you had to drop a perpendicular PM on QR, right? Okay, so that is what was required, and then you had to show that PM square, so PM is this segment, PM square you have to show is equal to QM into MR. All right, so if you see, we have right angle, number of right angle triangles out here, and then there is this theorem, children, that you can keep in mind for future also, important theorem, that in a right angle triangle, if you drop a perpendicular from the right angle like is happening here, okay, then there are three triangles that you can see here. This was the given right angle triangle, and then this perpendicular is making two more right angle triangles here. All these three triangles come out to be similar. Okay, so number of times this theorem or this fact will help you prove your questions or come to some conclusion. So keep that in mind, that in a right angle triangle, from the right angle, when you're dropping a perpendicular to the hypotenuse, you get similar triangles. Three similar triangles means your triangle QPR would be similar to triangle RMP, further similar to triangle QMP. All right, how does that happen? That they've explained to you here further. Suppose they are saying take your triangle MPR. MPR. This angle if you take as X, this is 90. If this is X, then this remaining would be 90 minus X. Okay, and if this is 90 minus X, this big angle out here was 90, so this would be x. And if that is x, this is 90, this is 90 minus x. Or maybe अगर हमने इसे x कहा था तो ये इसका complementary 90 minus x. So anyhow you can see that in all the three triangles you are getting one angle 90, one x, then the other 90 minus x. And same way here, 90, 90 minus x, then this x, and here this x, then 90, and this 90 minus x. So these three triangles being formed here are coming out to be similar. That can be observed. Okay. So this is how you can write what I was explaining you just now. And now what we are going to do is we will focus on the two small triangles that we had there. See these two, M, P, Q and M, R, P. So these two small triangles that we are getting inside, we will prove them similar. Prove them similar kya? We have already said that they are similar. Okay, and why are we taking them similar? Because if I take these two triangles, in these two triangles only you are getting all the dimensions that are required in the proof. We wanted one side PM, वो दोनों triangles में है, इसमें भी है, इसमें भी है. Then we wanted QM and we wanted MR. So whatever we want in a proof, we have to focus on the triangles जिसमें हमें वो paths मिल रहे हैं. So that is why we are choosing these two triangles which we are saying are similar. Okay, so therefore now the way of presenting a proof, we would pick up these two triangles. We would say in these two triangles MPQ and MRP, we will show the angles are all, any two angles also you can just show and get say that the triangles are similar by AA criteria. Okay, so we've got these two triangles similar, and if the triangles are similar, their corresponding sides are in proportion. Okay, so अगर आपने इसका QM लिया है तो QM के साथ दूसरे का PM correspond करेगा. So you will write QM upon PM is equal to MP upon MR. Okay, थर्ड साइड भी होती है बट हमारा प्रूफ इतने से ही आ रहा है. वी वर इंटरेस्टेड ओनली इन QM एंड MR and MP or PM. Okay, so that is why we are writing it this way. Or if you want, you can write the third proportion, but not required for this proof. Cross multiply. So you get QM into MR from here, and MP or PM is one and the same. So we can write this as PM into PM or PM square. Hence proved. See now children, question number 3. This time they've given you the figure that ABD is a triangle which is right angled at A, and then from A again AC perpendicular being dropped to hypotenuse BD. So if you see, the figure is exactly same as what we have done in question number 2 just now. Then they are asking you here to show that AB square is equal to BC into BD. So AB is this side here. So AB we want 2 times, and then we want BC this, and we want BD this whole big side. Okay, so वही logic जो अभी ऊपर था same will continue in this question as well children. Okay, वहाँ हमने ये two small triangles की similarity use की थी. अभी यहाँ पे according to the proof I also want BD, that is side of the big triangle. So this time which two triangles you will choose? I've already told you कि all 1, 2 and this big triangle 3, all three of them are similar. I've shown you how. 90 low, x low, 90 minus x, same way आ रहा था. Okay, so same logics for this question also children, but this time triangle का choice according to the proof you will have to change. So like for the first part, because we wanted AB, so AB is present in the big triangle as well as in this small triangle. Okay, then BC you have in that small triangle and BD in the big triangle. So you will take the small triangle ABC and DAB, the big triangle. Okay, prove them similar, they are similar, and then writing the corresponding sides in proportion, cross multiplying, you'll get your proof. Likewise for the second part, AC square. So AC is this, and then you want BC and DC. So this is exactly same as what we have done in part 2 just now children. Okay, then third one, AD square, then we want BD. BD is again the big side, and CD. So this time you will choose this small triangle out here, ADC, and with that you will have to take the big triangle BDA. Okay, इन दोनों को small and इस big को prove करो. तो one by one you will get all these three proofs. Just try to do it on your own. Otherwise, later I'll send you the written solution. Okay. Next, the fourth one is also quite simple here, children, where they are saying ABC is an isosceles triangle which is right angled at C, and then you have to prove that AB square is equal to twice of AC square. Okay, so if you draw the figure, then clearly it will be understood that a triangle which is right angled at C, ABC, and which is isosceles, so naturally hypotenuse के अलावा the other two sides will be equal, that is your AC will be equal to BC. Okay, so C के opposite आएगा आपका AB, so we have to show that this AB's square is equal to twice of AC square, right? So you need to apply two properties, Pythagoras theorem, because it's a right angle triangle, and then isosceles, that the two sides are equal. Okay, so first statement that either way you can do it. Maybe AC is equal to BC because the triangle was given isosceles. Okay, so AC is equal to BC, one equation. Another one, Pythagoras theorem, hypotenuse AB square will be equal to AC square plus BC square. Then proof में हमको BC नहीं चाहिए था, तो you will replace that BC by AC by this equation. Okay, तो इस BC की जगह भी हम AC रख सकते हैं from here. Alright, so clearly you're getting your proof. AB square is equal to twice AC square. Okay, so very simple. Now next fifth one you see is converse of what we have done just now in question number 4. This time again they are saying ABC is an isosceles triangle with AC is equal to BC. Okay, so AC is equal to BC and this condition is given to you. जो ऊपर proof किया था वो अभी given हो गया, that AB square is equal to 2 times AC square. Okay, and then you have to prove that this triangle would be actually right angle. Okay, so let's see how. Alright, so this was given to us that AC is equal to BC, and this was another thing given to us, which is AB square is twice AC square. We are going to split this. Twice AC square we are writing as AC square plus AC square. Okay, and then one of the AC can be replaced by BC from this equation. So in place of this AC we are writing BC by this equation. Okay, so we have actually got AB square is equal to AC square plus BC square. So we have shown AB square equal to AC square plus BC square, means Pythagoras theorem is valid here. So by converse of Pythagoras theorem rather we should say, this would be a right angle triangle. तो ये जो AB होती है हमारी, इसके opposite angle C, it will be right angled at C. Hypotenuse ये सबसे बड़ी side है. So if the side is AB, left over vertex C will be right angled. Now in the sixth question, children, they have given you an equilateral triangle now. ABC is an equilateral triangle with side 2A. Then you have to find each of its altitude. Now equilateral triangle, all three sides are equal. Okay, 2A, 2A, this side would also be 2A. And when all three sides are equal, naturally all the three altitudes are also equal in length. तो आप एक altitude निकाल के दिखा दो, that would be each of its altitude would be of the same length. All right. Another thing is that in an equilateral triangle, the altitude bisects the base. Okay, this altitude AD, so D will be midpoint of BC, as they've shown you in the figure also. So 2A हमारा पूरा side था. So if D is the midpoint, then this bit is A, and the other side also you'll have A. Okay, so that's the property of an isosceles as well as equilateral triangle, that the perpendiculars bisect the base. Okay, तो वो altitude आपके medians भी होते हैं, that way you can say. So whichever way. All right, so if the figure is clear, then you can also see that we have got right angle triangles in which we can apply Pythagoras theorem, because our aim was to find this altitude AD. So we know AC, we know DC, we can find the third side easily. Either choose this triangle ADB or maybe ADC, anyhow, any side. So after showing that figure clearly, you will simply present it as, you would say that in right angle triangle ADB, or as I said, you can take ADC also, the argument will be the same. So this time if we've taken triangle ADB, one of the right angle triangle formed, then its hypotenuse AB square will be equal to AD, that altitude which we have to find, and the other side BD. So from the figure it was clear which side AB was given as 2A, and this will become half, so it will become A's square only, and this we need to find, so that becomes whole square, 4a square. This goes to the other side, minus a square. So AD square is coming as 3a square. Therefore, AD taking root both the sides is root 3a. Hence, each of the altitude of this equilateral triangle will be root 3a unit.